Hi, welcome to Calculus, Chapter 1, Limits, AP Calculus AB, Evaluating Limits Analytically. So for the purpose of this lesson, for the NMSI lesson, I am going to be finding limits by factoring, by dividing out. So the prerequisite is that prior lessons included limit notation, finding limits graphically, finding limits numerically, finding limits using technologies such as graphing calculators or spreadsheets, properties of limits, and using direct substitution with limits. So let me scroll forward. There's a little, I'm going to start with a warm-up, and I'd like the students to recognize that they have these prior skills and they work on the first three limits that you see here, and two of them are kind of connected, they're the same, and the last one is just simplifying the expression by factoring. So the first two limits, giving the students just a moment to pause their video. And then we're just going to move this aside, and they would produce the limits that you see in the boxes. And that on the graph, produce the limit of 3. That as you approach 1 from the left and from the right, the left limit is 3 and the right limit is 3 as you approach the x value of 1. And then for the last problem here in the warm-up, we just have the students have worked on this and simplified the expression to where they should get this last answer here. Get a highlighted color. Okay, and so simplifying. I like to introduce the difference of two Q's because that's a topic that we often forget about. The difference of two squares is usually pretty well memorized at this point, but so throw that in there as well. So now your objectives here are to use the dividing out technique to evaluate limits of functions, use rationalizing technique to evaluate limits of function, but we're only going to do the first out of the two for this video for the purpose of the program that we're working on. So you have already learned how to use technology to approximate limits of functions graphically and numerically. So we'll continue to check our work, but let's review this method one more time. So pause your video and check these values out. So you see that as x approaches from the left, so x is approaching from the left, and x is approaching from the right on the other side. X is approaching the value of -3. So fill in the table and check back in just a moment. So the table is filled out. So it appears that when you plug in the values by direct substitution, you get the values that you see in the table for the function. And so it appears that from the left, you've got -5.0001, -4.9999 on the right. So remember the squeezing theorem. We're going to be able to say that in between those two values, that we're looking at a value of probably -5, and the pattern seems to hold all the way from -3.01 to -2.99. We can, of course, go on a graph and check that out. And you can see that, oops, sorry about that. So we have another way now that we can check this out, and this is dividing out technique to evaluate limits of functions. So in prior lessons, we had used direct substitution, and that's what we'll continue to do. So we're going to first start out by saying the limit as x approaches -3. We would do a direct substitution by plugging in -3 in for every instance of x. Now, I know that probably what I should be doing according to the AP College Board is I should probably say something like the limit as x approaches -3 of x squared plus x minus 6 is equal to -3 squared minus 3 minus 6, which is 0. And the limit as x approaches -3 of x plus 3 is equal to -3 plus 3, which is equal to 0. So they're both equal to 0, so that would give us an indeterminate form. So that means we have to either manipulate or do something. There are some more advanced methods that we use, but we have to do something else to be able to get our answer. So what we're going to do in this case, move this over to the side, is we're going to factor. So take this, we're going to say the limit as x approaches -3. Now, if I look at this, factoring the top is a quadratic, so I'll factor that as x plus 3 times the quantity x minus 2, and then the bottom is x plus 3. So I'm going to take and cancel the common factors of x plus 3. Remember that I really cancel out that factor of 1, and then I get the limit as x approaches -3 of x minus 2 then. So I have -3 minus 2 as my direct substitution again. So now I just plug back in, and it appears that I get -5. So the limit, I'm going to erase this stuff up here. So the limit is equal to -5. Usually it's a good idea, especially on our tests and our AP exams, is to make a final statement in the end. So we've done all of our work, go back, the limit is -5, which agrees with the numerical that we set up. And then here's the graph. You can kind of see that I have the graph here. It simplifies, remember, to x minus 2, except that x cannot be -3. So we have a hole in the graph at -3, -5. So remember, we called that removable discontinuity, point discontinuity as well. So, sorry, that was an alarm. So some of the strange facts, wanting to separate these because I remember having a hard time going over something like indeterminate forms as compared to 0. If you consider 0 divided by n, it doesn't matter how many times you divide 0, you still get 0. An illustration would be that if, for instance, Dwight Exotic has, can you see that picture? Dwight from The Office, made famous this summer after he depicted the Tiger King guy. Can't even remember what his name was now. I think his name was Joe. So I have no money, and I divide it amongst my n friends. They each get an equal share of 0, so it makes sense and follows the rules of mathematics. If I consider n over 0, n divided by 0, and first I'll take a look at 10 divided by 2, and then 10 divided by 0, because n could be any number except 0. In this case, 10 divided by 2 means to divide 10 into equal sets of 2, so we would have 5 sets of 2. But think about 10 divided by 0. In the second case, it means 10 equal sets of 0. So if I put all my sets of 0, I start counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, too many. Well, into equal sets of 0. It could actually keep going because it doesn't really make sense. I don't have to cancel those. It's just, you can't do it. It doesn't make any sense at all. So in that way, it's really just an idea that division by 0 and divided by 0 tends to either plus or minus infinity. And a good idea with your students, if they're not sure of this, even in a calculus class, have them divide 10 divided by 0.1, 10 divided by 0.01, and so on. Keep the pattern going to kind of see where the quotient leads, and it'll kind of get really huge. All right, so another one is you can take your cell phone and revert to Siri on an iPhone digital assistant. What's 0 divided by 0? She'll provide an answer. Just not the answer you wanted to hear, probably. Imagine that you have 0 cookies and you split them evenly amongst 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies, and you are sad that you have no friends. Most of you probably have heard this before. It's kind of old. But anyway, so it's an indeterminate form. It could be anything. So really when we're thinking about this and we're not really sure how to deal with this, you can remember that there's a special word for this. It's called indeterminate. It's not the same as undefined. It essentially means that if it pops up somewhere, you don't know what its value is or what it could be. For instance, if you have something like x over x, and you want to say the limit as x approaches 0, well, that could be 1, whereas the limit as x approaches 0 of 7x over x, that's going to be 7. So it could be different. So you want to make sure what the value is, so you've got to manipulate something. So find the limit using the dividing out technique here. So you see you have x minus 1 over a 4-term polynomial, cubic. And so what I'm going to do is I'm going to say the limit as x approaches 1 of x minus 1, the numerator, and you get 0. 1 minus 1 is 0. And then for the denominator, we have the limit as x approaches 1 of x cubed minus x squared plus x minus 1. I always tell my students it's always a good idea to do a direct substitution first. 1 cubed is 1, minus 1 squared is 1, so, and then plus 1 minus 1. So it turns out there we also get a value of 0. So the numerator and the denominator are both 0, which leads us to an indeterminate form. So that means that we're going to have to manipulate them. So we're going to take and we're going to factor the limit as x approaches 1, and we have x minus 1 in the top, but then we have this 4-term, so we're going to have to factor by grouping. So with the factoring by grouping, we have x cubed minus x squared plus x minus 1. So I'm going to pull out I'm going to take the first 2 terms, and I'm going to pull out an x squared, x squared, and that will leave me with x minus 1 plus, and then I'm going to put a factor of 1 in there because this is just x minus 1. So then I'm going to factor out the common binomial, which is x minus 1. I'm left with x squared plus 1. So if you recall what I'm doing, can I highlight this with a yellow? I'm pulling out the common binomial. Can't really highlight it too well. So when I pull out this common binomial from the 2 terms, picture it as you're pulling it out front using the reverse of the distributive property. You're left with x squared and then plus 1 that you pull down in your second factor. Bringing that over into your expression, you have x minus 1, the quantity times x squared plus 1. And we're going to cancel the common factors of x minus 1. They become 1s because x minus 1 over x minus 1 is equal to 1. And now we're taking the limit as x approaches 1 of 1 over x squared plus 1. Now we can do a direct substitution, and we end up with 1 over, make a little more room, 1 over, 1 squared is 1, plus 1 is then, we might as well put the squared in there, and our answer then is 1 over 2, or 1/2. You could check your work with a graphing calculator as well. I think that's always pretty helpful. A picture is worth 1,000 words. So I could put the answer here, but in the interest of time, I think I'll just put that here, and I'll come up top, and I'm just going to say equal 1/2 up the top. Okay, and then the next one, another issue with the difference of 2 cubes. I like to introduce this because I think that sometimes students forget this. I know I did. So I look at this, and again, one of the other mistakes you can think when you see this 2 and the 8, you think, can I take the 2 into 8? So you have to be careful of all this algebra that comes back into play. So what I'm going to do is say, okay, I'm going to take the limit as t approaches 2 of t cubed minus 8, and the limit as t approaches 2 of t minus 2. And in both cases, I'm just going to say you get 0 for both of them. So you do have an indeterminate form. I often say this after a while, the students get used to it. An indeterminate form. So then that means that we've got to factor. So I'm going to come down here. I'm going to say that, okay, we have the difference of 2 cubes. The limit as t approaches 2. The numerator then, now recall that we're using this difference of 2 cubes up here. So I'm going to drop it right in here as t, let me make a thinner pen here. T cubed minus 2 cubed is equal to, so we have that SOP. We have t minus 2. I'll make a brighter pen here, so I'm going to make it pink again. So I have t minus 2 times the quantity t squared plus, so the SOP method, same, opposite, and plus signs, so I'm really just talking about these signs. And so I keep the bases in the first one, same sign, minus, it's minus here, and then t squared plus 2t plus 2 squared, which of course is 4. Okay. One of the mistakes, students will often put it as t minus 8, so you have to be careful of that. So let me go back to the blue now. So if I factor it, I have t minus 2. And then I have the longer trinomial, t squared plus 2t plus 4. And remember, always when you're plugging in with direct substitution, you have to remember to follow order of operations. Canceling, now we have our expression factored. We cancel. And now we take the limit again. And most of the time, as I'm instructing, I'm going to write this out. Sometimes when you don't, I kind of get you. Like some students will, at that first step, go ahead and direct substitute and give the answer. So I'm just going to rewrite this as t squared plus 2t plus 4. And then I'm going to plug in, direct substitute. So I get 2 squared plus 2 times 2 plus 4. And that will lead me to an answer of 4 plus 4 plus 4, or 12. So the answer for our limit, and this around here is a little smaller. So the answer for our limit then is equal to 12. Again, you could verify this on a graph as well. Check using that. I'm just going to leave that up to you. Now, for your exit tickets then, there was something else I was going to say, but for your exit tickets, you've seen this. Now I want you to discuss this using vocabulary, so to speak. Limits, continuity, other math terms, removable, non-removable, point, jump, or infinite discontinuity. So to compare and contrast. And remember, compare and contrast, you want to say, how are things similar? How are they not similar? How are they dissimilar? So how are they alike? How are they different? And make sure that you're using the mathematical vocabulary there. Flowcabulary. Then your second exit, you're going to use the dividing out technique to handle this and get your answer. And what I'd like you to do for both of these with your teams, I would like you to go to the Jamboard that I've set up and to put your team 1, 2, 3, 4, 5, 6, and put your team number on that same page, and then show your work or show your explanation for the first one, and then show your work for the second one with justifications. Okay, and then for the last thing here, we have a dividing out technique board. Let me see if I can sweep this off here. Just filling in the blanks, and usually what I'd let you do is take your time and see if you could fill in the blank without me showing it to you. So students would do that, and there you have it. And then for a follow-up, then I have a Schoology quiz, and take the time to go back and do the review quiz. I give you 2 opportunities to take that quiz in Schoology, our learning management system. So I'm kind of talking to you, Nimsy, and I'm talking to the students, but everybody will be on the same page, I'm sure. As you're working on the problems with your teams, I want you to ask yourself, what could possibly go wrong? A very wise teacher once told me, go forth and be wrong. Be willing to make mistakes. And last week I heard Dr. Bernard Harris, who flew missions for NASA. He said that we need students to not be brittle. We need them to accept disappointments. And when they fail, or when you fail, he said, it's because you are trying something hard. It's okay to be upset and disappointed, but not okay to give up. I would urge you to search for Dr. Bernard Harris and Dr. Massimino, also a NASA pilot, or NASA, is he a flight engineer? Or he was, but he did fly missions and did spacewalks. So I thank you for this opportunity to show you this. And if you continue the lesson that you see on the script, it does go into the second part having to do with rationalizing or rationalizing either the numerator or the denominator of an expression so that you can take the limit. Thank you so much. Have a good day, and I've learned a lot.